Hi, everyone. Today we are going to look at our work from Unit 4, Lesson number 9. We're going to learn now how we can use um, the what we call the arc or inverse trig functions to find an angle. All right, we've in the past used a known angle with a trig function to find a missing side as long as we're given another side to kind of work with. This is going to require us to use a lot of the same thinking, but we're going to use a new type of function called the arc or inverse function, and I'll show you how that's different here in just a second. But now we're going to, again, start off by writing a regular trig equation. The difference now is that our unknown is going to be the angle as opposed to the side length. So they want us to find angle T here, which is right here, okay? So there are, and again, we're gonna also remember SOHCAHTOA, right? All of our work starts here as well. Um, and so what we have to figure out is based off of the information given to us in the triangle, how do I put angle T together with other stuff I know? Well, I know angle, or I know this side 9 and I know this side 8T. Those are given. I have to figure out what relationship do they have to angle T. Well, 18 is the hypotenuse. That's the longest side. And again, it's also opposite 90, right? Even though I don't have this side up here, I still know it's the longest side because of it being opposite 90. The side of 9, SR here, is the opposite side, right, of angle T. So in this problem, I start by using the sine function. So I'm going to say the sine of angle T is equal to O over H, right? Which is going to be 9 over 18. Now here's the tricky pitch here, right? So in order to solve for t, what we're going to do is we're actually going to use the inverse function, right? So it's kind of like, if you multiply on one side, you divide on the other. If you're adding on one side, you subtract to the other. If you're doing the sine on one side, you can remove it by doing the opposite or the inverse of the sine, not opposite, the inverse of the sine on the other side. So what we're going to get is the measure of angle T is going to equal the inverse sine. So the way that we indicate inverse, sometimes you'll see an ARC in front. So that's why I called it an arc function earlier. Most calculators use this -1 symbol, and then you plug in the fraction that sine equaled. Okay. So on Desmos, you'll need to, again, if you're going to use Desmos, just go to the functions link, and you'll see again sine -1. But we'll show you how to use this during class as well. So I'm going to use my TI calculator. Make sure again you're in degree mode. So if you're using Desmos, make sure you switch the tools to degrees. But I'm going to do the inverse sine of 18, of 9 over 18, excuse me, and I get my answer here, and it says 30 degrees, right? So this is just flat out 30 degrees, no rounding needed. Fantastic, right? It's not 130, by the way, that's just a blank cursor. All right, so again, we figure out what angle do they want, what sides do we have, put them together with a trig function and make an equation, and then use the inverse to unlock the angle. So we're going to try this again. Again, we're going to use SOHCAHTOA to help drive this problem. So always have that written out somewhere. So they're asking here in this problem to find the measure of angle D. So that's right here. They're giving us side 9 and the side 10. Well, 10 is the hypotenuse, right? And 9 would be called the adjacent side this time, right? The opposite side would be BC over here. So that would mean the adjacent side is right here. Again, it means next to also, right? So CAH is what connects all of this together. So this is the cosine of angle D is going to equal the adjacent side of 9 over the hypotenuse 10. Right, so that would be the equation we would set up. And this tells us that we could find the measure of angle D as the inverse cosine of 9/10. Okay, so the inverse cosine. So if we're trying to get an angle, we got to use the inverse, right? Cosine, usually we put an angle into it. Inverse cosine, we actually put a cosine value in to get the angle back out. And so I'm going to do very similarly to last time, the inverse cosine of 9/10. That answer is more of a long decimal answer. Again, you're expecting an angle measure, right? Just kind of think about it too, based on the answer you're given. This is a kind of a small angle, but it's still going to be, somewhat sizable. The answer that I got here was 25.842. It says to round to the nearest tenth, so this would be 25.8 degrees. Right? So again, that makes sense. That's kind of a smallish angle, but totally fits within a right triangle. Makes sense here. The last one we're going to look at is going to look at our third trig function. Again, make sure you are considering all three options based upon what's given in the problem. But we're going to start here with angle V. Okay, that's what they're asking for. So we're going to look at angle V here. From angle V's perspective, I see 3.6 and 9.4. These would be the opposite sides and the adjacent sides respectively. Okay, right? We don't have the hypotenuse here, the longest side. So we have O and A. This is what tangent is built for, right? So the tangent of angle V is where we're going to start this. We're going to say the tan of angle V is going to equal to the opposite side, which is 3.6, divided by the adjacent side, 9.4. And we're going to say here that the measurement of angle V will be the inverse tangent of 3.6 over 9.4. Right? So again, we want to use our correct calculator. Make sure you're in degree mode. And this one was considered a more challenging question just because it had decimals, but you're using your calculator anyway, so it's not really that much more challenging. All right, so we get an answer close to 21. This is 20.956. Right, da 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 da. Since we're rounding to the nearest tenth here, this would be 21.0. Right, 21.0, which I don't think you need the zero here. Just use 21.